I think we're live. Welcome back to the stream. We have a slightly different configuration on the diode zone side today. I happened to notice this morning that diode zone, our PureTube server, is falling over due to lack of memory. It has depressingly little memory right now for reasons that are probably outside the scope of this stream, but it can't really handle more than a couple of transcodes at once, and so the one background transcode that it currently runs, plus a couple of live streams, one of those being kind of high resolution, was enough to start making it get into out of memory zone. Someone on Twitter was like, add more swap, and like, well, yes, it doesn't have any swap right now, and that's actually for a reason, because if it has any swap, instead of just out of memory killing whatever process is a problem, the entire system becomes unusably slow for an indeterminate amount of time. So it might last slightly longer if swap is enabled, but the failure modes are much worse. Anyway, I turned off transcoding on diode zone, so you're getting the raw feed that my OBS is producing over there. Maybe a little lower compatibility and no 720p option, but it should be a lot less server load. Anyway, welcome back to the stream. Live over on Diode Zone as well as YouTube, Scanlime-in-progress channel, and twitch.tv/scanlime. Tuco's been over here chilling on the chair for a little while. There he is. Our relaxing little tiger over here. The stream's going to be kind of a continuation of yesterday. Yesterday was basically kernel debugging the Pcmcia driver for this old 486 voting machine motherboard. And it seems to be basically working in that it's detecting that I've inserted a card and it's trying to map the memory for the card information structure. And unfortunately, the card information structure is failing verification. On yesterday's stream, we got close enough to actually hex dump out what it was receiving for the card information structure. And to my horror, it was actually a copy of the first 4 kilobytes of the video BIOS. So that indicates something weird is going on with the memory mapping hardware on this board. My understanding of this is that the same fundamental CPU resources are used for mapping the BIOS and mapping the PC card slots. So something is getting crossed with the configuration here. And I've got a bunch of questions. I did some reading on, I think the two documents that are going to be most useful for us here are the PC card specification itself and the manual for the system on chip that this all runs on. This runs on a 486 compatible system on chip, which has its own flavor of mostly Intel compatible PC card controller, but it's not entirely Intel compatible, and we might end up having to tweak some of its register values. And my first couple of questions are going to be like, what mode did the BIOS even leave the system in? Like, how is the BIOS even mapping itself into memory? How is the BIOS leaving the PC card controller configured? There's this set of standard registers that Linux knows about, but there's also a set of non-standard registers that are part of the system on chip configuration that I don't think Linux would have any idea how to access. So we would either have to write, if those registers turn out to be the problem, we would have to either write some code for Linux to set those properly, or if everything can be sort of relegated to something done during boot up, we could just basically extend the watchdog timer setup code that I've got in the grub config file. So I've got grub just issuing some raw I/O accesses during boot to set up some of the hardware, and we could continue that if necessary. Welcome back to the stream, folks. Alright. Make Tuco very slightly smaller. Not that one. This one. Oops. This one. If I click the wrong thing in OBS, it seems... I don't know what's going on here, but I've got something with my OBS setup that's making its UI extremely laggy. I haven't debugged it, but I think it's some interaction between all the different video capture drivers I'm using on this system. Because I've got two separate deck link drivers and a bunch of USB capture devices on this system. I might try moving this OBS setup back to Linux. When I set this up originally, I think back in like 2018, I tried Linux and had some kind of problem with the video input drivers, and so I went back to Windows, and so I've been using Windows for this particular streaming setup. But maybe it's time to just roll the dice and try some different software again. I moved my main workstation to Linux, and OBS has been pretty happy with the hardware there, which is largely similar. I think the only thing like super Windows specific that I'm using right now for streaming is Voicemeeter, but I don't love Voicemeeter. It's okay, but I think I could like enjoy something Jack based if I moved this all to Linux. Anyway, I don't really want to talk about operating systems because every operating system is trash, and anybody who has like a favorite operating system is probably having a conversation that I don't want to participate in. Oh man, I think we were going to switch back to the other computer here actually. What was I even doing on this computer? I was being all optimistic the other day and hoping that we would get some kind of X11 like input forwarding stuff going on. And so I wanted to use, I think somebody mentioned on a previous stream using Synergy, which is an application for kind of remote controlling one computer from a different computer by sort of virtually moving your mouse off the edge of the screen onto the other computer. And that actually works across different operating systems by having like a local daemon that runs on your computer and connects to all the other computers that are in your little mesh of screens and coordinates the handoff of input devices. But I was spacing out on what this was called during the stream, but there's this tool that I used to use before Synergy was even a thing called X2X, like the letter X, the number 2, the letter X. It's a similar concept where you move your mouse off the edge of one screen and it sort of flows onto a different computer's monitor. But this was entirely just for X11. It wasn't cross-platform like Synergy. And I thought we could use that because it might be simpler. It might be something we could send. This was before I was focused on getting the network card working because I didn't have that hardware in my hands yet. And so I was thinking about forwarding a single X connection over the serial port and thinking that using X2X would be a good match for that. And then I was trying to actually test that out using XNest to prototype the kind of destination X server. And I'm pretty sure X2X doesn't work with Wayland. Wayland was really intended to have security such that individual X clients don't just have complete reign over your input devices. So I thought it was useful to have a separate computer here that I could switch over to Xorg. So this is our friend Fishbowl, but I think we're going to go back to our vegetable friend. Close all this junk. Alright, this whole thing. So we got a PC card spec. The other spec we're going to want is... Okay, well that was the PC card meta format specification. We want the documentation for the system on chip. Sure. that comes in these two parts. Well, three parts really. There's a manual, a data sheet, and a register data book. The data sheet is mostly about electrically how the chip works. The manual is mostly about how to program it, and then this register book is a reference for all the configuration memory on the chip. Software is bad, give hardware a hug. I kind of agree with that. I mean, hardware is bad too, but in ways that are less pervasive than software, I guess. I like hardware because the ways in which hardware are bad tend to be limited by physics, whereas software is mostly limited by human ambition. And so both are very bad, but hardware tends to have tidy constraints around it. Oh gosh, there's a comment that someone likes the stack of bins. I need a better solution for that, but I'm glad you like it. I've got a weird set of like different sizes of storage space here right now. Tried to keep this filming area mostly clear, but I've got area for like more messy stuff in like other parts of the place here. Okay, registers. So this document is very big, 520 pages here. And this is just like a summary of all the registers. Register Set Reference Manual, 1996. So some of these are related to what you would normally find on a PC-compatible system. That's this big chapter. Some of these are very specific to this particular system on chip. They call them chip setup and control registers. That's what I'm most interested in right here. So this is like how you configure the GPIOs, how you configure the DRAM controller. I don't know technically what the underlying hardware feature is called, but there's basically an underlying memory mapping unit in this chip, which is not the x86 like protected mode memory mapping or anything like that. It's a separate layer. So it sort of occupies a similar position to like a bus bridge memory controller or like an IO MMU or something like that in the system, where it's translating between what would normally be bus addresses and the addresses that are used in particular sets of peripherals. So there's this underlying memory mapping hardware. I think the deal is that there are 10 of these memory mapping windows, which are configurable to between 64 kilobytes and 64 megabytes in size each, or something like that. You can place them relatively arbitrarily in memory. I think they have to be above the 64K boundary and maybe below 1 megabyte. So they can't go like absolutely anywhere, but they can go in a configurable location. And there are a bunch of them, but a finite number. And I don't know how they're being allocated in this particular system. So I think they're related to maybe how the BIOS is being mapped. There is this other feature that you can use to map the BIOS linearly, but I don't know if that's what they're actually using here. I think they might actually be trying to map the BIOS in separate chunks for like the system BIOS and the video BIOS. So one sub-job here is to figure out, are they mapping the BIOS linearly? Are they using these MMS windows for something like BIOS mapping? Like the general problem here is I don't know what the interface is between like what the hardware / BIOS on this board expects and what the kernel expects. Like how do we actually get those two to agree? So depending on how the ROM chip selects here and MMS windows are configured, the board could have a varying amount of resources left over for Pcmcia. And I don't know exactly what's going on here, but the behavior that I'm seeing as of the last stream is when I try to put a PC card in this system, instead of mapping the PC card's configuration memory, it just maps another copy of the video BIOS into the PC card configuration memory window. So it's pretty weird. Pcmcia is pretty weird all on its own, and like legacy x86 stuff is pretty weird, and this is just kind of a mashup of a lot of that. I'm going to mostly have the camera on the cat, but here's the hardware we're working with. Button stuck. This button requires an amazing amount of attention to keyboard focus. Okay. So yeah, this machine is normally in like a big suitcase size enclosure. I just have the relevant pieces attached together on my desk here. I've got a Raspberry Pi down there acting as support equipment to drive a card reader and a serial adapter. But then the motherboard is this thing over here. It is booting off of that CF card in the front with the tape on it. And back here, where I'm pointing in that blurry zone, is the actual system on chip. And then in front of it, the other large chips are an I/O expansion chip and a graphics controller. Autofocus is really interested in that CMOS cable. There we go. So yeah, you might be able to see an AMD logo on that large chip in the back. That's the system on chip. And we've got 2 PC card slots. One of those I am trying to run an Ethernet card in. You can also see that little sort of front panel assembly on the back that has a text LCD and a button and a couple of rotary switches. This is also a touchscreen. The touchscreen controller is this 3M part that was just an OEM module with its own firmware, and it attaches over a serial port. We theoretically have a driver for that, but it needs a little bit of configuration and debugging before it'll actually work. So I think the deal here is I'm going to get the system back into kernel GDB like we were doing before, but then try to do some just poking around in the status of the MMS windows here and the Pcmcia controller. So now I'm going to rebuild the disk image. So I've already got build results here, including a full-on disk image and debug symbols for the kernel and grub and various user space stuff, including the X server. And I've got that Raspberry Pi connected to the serial port. Alright, let's boot this up. Maybe get a view on the screen first. Maybe less glare. Oops. Still glare. Very glare. Why have we not been auto-mounting sysfs lately? That's been annoying. Do I just need to add this to my fstab? Does this work? Oh. I guess I'm not mounting anything properly. That's interesting. Why are my init scripts so unhappy? Okay. That's fine. Okay. What? Invalid L structures. Where? Is it talking about the debug info or something else? That's interesting. So I have all these great debug messages now. The messages I really want are these i82365 set memmap and set iomap. So the point we reached on the last stream was noticing that the memory map is being performed, but seems to be targeting the wrong device. So I want to take a closer look at the actual memory map itself. One potential problem that I saw when I was reading the documentation is well, there were a couple of potential problems, but there are a couple of different modes that the PC card controller can be in, and depending on what mode it's in, you might have a different number of memory mapping windows available, between 1 and 5 windows per card slot. So I want to know how these are being used. It doesn't look like Linux is trying to even use multiple windows though, so if it is just using one window, then maybe that's not a big deal. So I wanna check on that and see how that's doing. Okay, we're still running this manually, I guess. Pcmci socket startup. Okay, and there's the socket that we allocated, or the mapping range for the socket, rather. So yeah, I want to know whether this is hitting a warning that I noticed in the documentation about putting the Pcmcia mappings in an area that overlaps the Rom mapping. So we might actually be doing that here. Let's have a little bit more light. I want to know if it's in the standard mode or enhanced mode here. That's the warning I was looking for. PC card controller memory windows should never be opened in any region that is enabled for linear ROM chips like zero decode, which is the BIOS. Whether or not shadowing is enabled, failure to adhere to this may cause improper system operation because no internal address decoding priority is defined in this regard. So I don't know exactly what that means, but that seems like it might plausibly cause some of the behavior we're seeing if we do actually have an overlap between the ROM region and the PC card region here. Because the symptom here is that the PC card window is getting decoded as ROM. I thought there might have been a way to configure that accidentally using the register set, but I think what's going on here is that Linux is requesting a memory mapping specifically through the i82365 window registers, and I don't see how that could be interpreted as something that is not requesting a mapping to that particular card socket. So unless there's some kind of resource conflict or some like logic board level logic is set incorrectly, I don't see how we're mapping the incorrect thing here. So Let's get the debugger attached again. Okay, that's KDB. Let's go back to GDB. Really not used to ZSH yet. Okay, symlink is still fixed. Okay, we have GDB attached to the kernel. Here we are there. Okay, let's open up the i82365 driver. Yeah, i365 set mem map. What is GDB doing here? No IO map breakpoints? Can we get back into the debugger? I don't have sysrack on the keyboard here. I don't know why I lost it there. There's a question about keyboard shortcuts for dragging windows. Usually it's like Alt or Command, depending on your environment. I didn't successfully get any debug output out of this module either. Okay. I don't think that turned on any new debugging. Okay, dynamic debug is the kernel feature I'm trying to use here. Where's the... Maybe it just has an extension I'm missing. The module is definitely just called i82365. Is it possible it's not actually mapping any memory properly? That would be weird. Like, worried about that PCIC, like, oh, is that PCI? No, it's Pcmci card. Probably simpler to not worry about loading and unloading the module here and just to turn the socket on and off to trigger the problem. Did it just optimize out this function entirely? Probably. Okay. Oops. What if I get type? Oh, that was an eject operation, and I still got a set IO map there. Looks like the end of an IO map. Continue. What is the easiest way to break into the debugger again? Oh, is there not just a command that immediately int3s? Oh, cool, that does work. Echo G to sysrec trigger. Okay. So let's see what's going on inside Pcmci set map. Actually, how many of these do we get per? Is that 5 for an eject? Okay. And 5 for an insert. Yeah. So if Linux is actively trying to configure 5 mappings per slot here, we are definitely going to have trouble if the mappings are in the mode where they only have one hardware mapping unit. I guess let's try to figure out what mode the system on chip is in. What's the easiest way to just do CPU I/O in the debugger? Can I just do this? It'd be interesting to know how to do this from the Linux debugger, although it's tempting to just do it from grub. Duke looks comfy. Grub. All right. So yeah, here I've got stuff like in byte, out byte. And just do stuff like that. So And the register manual. We did write a little tool to dump out all of these registers a little while ago. I just want to read like a couple of bytes right now, though. Okay, PC card extended features register. Okay, I want to read F1. So that puts the PC card controller in standard mode, where we definitely only have one memory mapping unit available. Yeah, so this says 2 are dedicated, which means that each of the 2 PC card slots has one mapping window always, and then 4 of the mapping windows can be allocated to one slot or the other. So that's something to be aware of. Let's try to figure out how the Rom mappings work. Oh, it looks like linear ROM 0 decoding is on by default. And you set these to 1 to disable the regions. Yeah, let's see how these are set up. 21. Seven. C, D, and E are all enabled. Does that mean we don't have any linear decode? Boot vector. That is at the very, very top of, I guess, the bus address space in this system. I don't think we care about that. wait, no, these are active high. And these are just named after the hexadecimal prefix on the segment. So C, D, and E, I guess, are entirely redirected to ROM CS0. Okay, so like one part of this problem is that Linux is probably stepping on this chipset peculiarity where we have this big old ROM mapping that we can't actually use for Pcmcia mappings without confusing the mapping priorities in the chip. That's quite likely a problem. It might be just a bigger problem, though, that there are 5 memory mappings that we are supposed to have access to, and we don't actually have probably more than one. There's a mode we can enable that'll give us all 10 mappings, 5 per slot. I think that'll interfere with how we're doing our ROM mapping, though. Oh, I guess not, because the MMS and this linear decode are separate. Okay, so maybe there is an actual easy solution to this. I think the easy solution is we put the Pcmcia controller into advanced mode, or extended mode, or whatever they call it, so we get all 10 mapping windows. And then we tell Linux to just don't even bother with this chunk of memory, just like stay out of the linear CS0 region. And then we can keep using linear CS0 for BIOS decoding. I should make sure it's not intentionally using MMS windows for anything. Let's do that. So this 7 here means that CSEG, DSEG, and ESEG are all enabled for ROM CS0 decoding. And it says either ROM CS0 or DRAM based on bit 5. That's for shadowing, which is off. This is like a performance feature that lets you copy the ROM to RAM on the assumption that your RAM is faster, but we're not using that here. Cache enable. Gosh. Okay, let's check on the MMS windows. The MMS windows can be used to access ROM. That's how I was dumping the ROM a while ago. I think we already looked and it wasn't using these, if I remember right. Let's just check again really quickly. These are write protects. Gosh, the naming here is so confusing. Like, what is different about A and B versus C through F? Yeah, MMSE is pointing to ROM chip select 2. I don't know if that means anything. I don't know what's attached to ROM chip select 2. I know chip select 0 is the BIOS, but I don't know of any use for the other two right now. Yeah, and this was some IRQ configuration stuff. Yeah, well, let's see what happens if we put the card controller into extended mode. Okay, there's also an opportunity to increase the clock speed, which I don't think we want to take. Enhanced mode. Okay, PC card controller is in enhanced mode. We could just put this in the grub config. What else? Cut mem. Let's see if that does anything. Decompressing. So I think if that worked, I should see a reserved region in the memory map. And then maybe the PC card controller will act differently when I add the driver for it. No reserve zone there? No memory mapping? That's interesting. Oh, maybe the cut mem worked. This E820 map seems reasonable, right? Right, E820 remove. Interesting. I think it's failing in a different way, at least. Which of these commands? Are we actually just not recognizing it? Maybe extended mode is not working and we should try just the memory map adjustment. Yeah. There's a request for some context about this system. It is a 486 based voting machine that I'm messing with trying to get Linux running on. I've got Linux basically running, but it's pretty low on hard disk space, and I'm trying to get the PC card slots working so I can add some networking to it. Basically ruining it by connecting it to the LAN. I think we're still not successfully restarting it all here. It's fine. Moving that A segment. That is a big old ROM mapping. There's a lot of flash memory on this system that's not being used. I mean, it's much less than a megabyte, but it's like a lot in BIOS terms. Okay. This is also not working. It's acting like it just is failing to make that memory mapping, but I would expect it to complain if that was the case. Oh my gosh. Missing all my favorite file systems. I should just actually make a new image with a new grub config and a new FS tab. There's our friend. Well, we've got that interrupt at least. Oh. Not crazy, right? Those weren't showing up before. Okay, we've got a card now. I don't know why we have a card now and we didn't before. We still have no obvious I/O mapping. Ah, look at all those mem maps. Interesting. And they appear to be on the first controller. Oh. We've got socket 1 sitting there at CC000. I thought we prevented that. Interesting. I feel like we're going around in circles here. This is acting suspiciously like our memory table just got reset or something, so that this memory is now accessible and a bunch of it got allocated. I wonder if the system would be really annoyed with us if we unmapped the BIOS. Because that would be another way of preventing this conflict, right? So for some context, this system is trying... Well, I wouldn't say trying. The system is somewhat 486 compatible because they used a bunch of kind of off-the-shelf PC-flavored embedded parts. It's not really trying hard to be PC compatible, though, and the BIOS is a little bit weird. So far, the two leads I'm following on this card slot are the difference between the standard and enhanced mode on the controller, which really the standard mode is basically missing most of its memory mapping windows, and the enhanced mode is basically standard, but still not quite standard. So that could be the problem. And the other lead I've got is that there might be an issue with having the memory mapping region for the PC cards overlapping where the BIOS is mapped. And I think Linux thinks that it's putting the mapping in this hole in between the video BIOS and the system BIOS, but in reality I don't think there actually is such a hole. I think it's just one big device. I don't really want to clean this mess up. Well, yeah, let's get a clean boot and maybe go back into regular kernel debugging. I don't know if that actually needs an argument. PC card D. What's up with the card slots? Right, I would have thought PC card control LS would at least list the slots here instead of giving me nothing. I don't have S-trays. Plug the slot. Just reloading the module. I don't know what else to do at this point. I wanted to actually look at all these call sites, but on the way in rather than on the way out of loading the module. Okay, this is just turning off the mapping window. I think these are all disabled so far. What is the call stack like? Pcmci init. Oh, are these just intentionally zeroing all the mappings then? It's funny that they just kind of hard code these loops to go over 2 IO mappings and 5 memory mappings. Are we just not getting as far as actually even trying to map the memory now? Who even uses this entry point? Right. Whoa, hey Tuco. Ah, Tuco. Hey. Hey. What are you saying? Thanks, Hugo. I'm testing your mic. Sure is a sensation. To go. Who's using this? Tuco, what are you chomping on? Are you chomping on my glasses? Oh, honey. Tuco likes that bird sound. Tuco, what are you doing to my glasses? Gosh, what is even in charge of this memory mapping? Tuco. Sure seems like there's some source code this is not searching. Oh, too good, don't do that. Available resources, man. Platform devices. Okay, why does each socket have a separate set of available resources? Oh, hey Tuka. Are we hitting a breakpoint? Oh yes. We are hitting a breakpoint in Pcmci set memmap here. Let's look at that. Oh, cool, we're trying to read the CIS now. Okay, so we were getting a bunch of memory mapping requests just during card load and unload. I think that was just like housekeeping. I think the actual first like real memory mapping request we get is to read the CIS to try to figure out what kind of card was just inserted. Pcmcia memprobe. Haven't seen that tag before. This is still in that problematic region, in that C segment. Potentially problematic region, I should say. I should find out what that Pcmcia memprobe actually comes from, because that might be related to the definition we need to change. So anyway, I expect this is going to fail by reading bits of the BIOS again. I can step through and watch how this operates, though. Oops, I meant to step inside that, and I stepped over it. Whatever. Maybe we won't go inside that. What about this one? This one looks very similar. I don't know what's different about this one. Let's actually step through this one this time. Okay. Turning off the window. Oh, base is the base address for this particular socket, I think? I don't know. And this is just doing like indexed register access over ISA. So yeah, I think here base is the per socket indexed register base, and then I is the calculated memory value that we've got here. And turning on the region. Okay, what is this Pcmcia memprobe? Not what it was called. Oh, that would do it. I was only searching include directories. Hmm. 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 I feel like I'm looking at some kind of fossil record. Oh, Tuco. Yeah? Hey. Loud boy. Oh yeah, thanks for the update on diode zone. This is the first time I've tried out diode zone without the transcoding in a while. There's a question, how am I controlling the computer? The voting machine one, I've got a keyboard and there's also a serial port. The other computers here, mostly a keyboard and mouse. I do have a sort of a KVM switch-like thing for controlling multiple computers here. The input part of it is actually something that I have another video on. It's a modified USB switch with sort of a remote control to it. And then on the video side, I've got a separate video switch, which is just like a KVM switch with an infrared remote. Go. Should we be trying to get some of these cat sounds? He's got some good purrs right now. Hey, boy. Happy cat. probe. That seems ominous. It does look like it's trying to sort of experimentally determine where this memory window can go. I guess technically this is all a separate device that is not the Pcmcia controller, but is a resource manager. Do you go? Pcmcia non-static validate mem. Oh yeah? What's that about? To go. I don't even actually know where the memory windows for Pcmcia should be on this system. Duca, you're so in my seat. Oops. Duke. There's not quite enough room, huh? Duco. All right. You want that again, Jacob? Oh, cat. So this is the Pcmcia resource driver. It looks like there's a sysfs interface where we can just manually add memory ranges, which might be interesting. Oh yeah. Can we use the serial terminal for this? Yes. Nothing obvious beyond just the module related information here. Yeah, where do these memory ranges actually come from? So I think these second two will not be applicable because I don't think we can map above a megabyte on this device. And then that first one is the one that I think is problematic because it's overlapping with the ROM region. Huh. This non-existent resource we're freeing looks like the I/O port for the Pcmci controller itself. That's weird. Okay. I think I still have a breakpoint here even though the debugger's disconnected. So I'm I do have to reconnect the debugger before loading the modules, I think. Yeah, I guess I'm not going to recover from that. Okay. I think I've got to set that breakpoint before loading the Pcmcia modules the first time. Reboot. Water bottle that quietly screams at you as you drink from it. Okay, terminal again, switch to kernel debugging. Okay, breakpoint on do mem probe. And then it's easier to just use this terminal. So no grub options or anything. Probe I-82-365 with a typo and without a typo. And now that UDEV thing. Pcmci socket startup. I should find out if this actually is supposed to take a parameter. Let's take a little side trip to debug, or to figure out what that should actually even be called with. Is this in Pcmcia utils package? Yeah, Pcmcia utils. Are these actually in the Linux source tree somewhere? Alpine here is downloading the sources from Arch for some reason. It's like a random tarball from 2012. Where does this package even come from? This class Pcmcia socket. Add available resource. Yeah, it sure seems like this is the thing that I need to understand next. I guess the argument is supposed to just be a socket number. Did I try calling it with 1? Yeah. Is this program just dumping a config file into sysfs? Where does this even come from? Hmm. Oh, a card manager to Pcmcia utils doc. Ah. New as of 2.6.13. To use the new Pcmci utils, it's a requirement the card manager is not started. That's cool. This is mostly stuff we already knew. I was hoping this would tell me the format for the config file. That's great. This is what we need to change. This is definitely in need of a modification. Is this installed in that same usual place? Okay. So I think these ports are fine as far as I know. Pretty sure high port numbers would not work here. I don't think we want this high memory. And then this range needs some adjustment. What's actually free? Right, like that's just entirely relying on the region between the two ROM segments, which I think I want to avoid. Well, I don't know if I can put it in that low kernel memory. Like, I don't know if I maybe have to move something else out of the way first. I don't think I can do that. I don't think I can do that either. There's a question about what Linux distro we are running. We are currently running Ubuntu, Debian, Arch, and Alpine. And as well as Windows 10 and Windows 8.1. Did we lose our CMOS memory? Yes. Will it reset the watchdog in time? It's a race. No. Okay. Always exciting when the CMOS memory is randomly destroyed. I feel like using cutmem was a little bit too drastic because this memory is not generally unusable. Like, it's perfectly fine DRAM. There's just a particular conflict in memory mapping hardware that I think might be hitting, and I'm trying to avoid that. Okay. Okay, I don't know why at this stage PC card control is showing me no slots. That's not going to be useful for anything. Oh, because I don't have sysfs mounted. I really need to fix my FS tab here. I don't think that's even the problem though, because it looked like my FS tab mounts maybe weren't happening. Yeah. Something wrong with my init scripts that I haven't debugged yet. Okay, that's much better. Gotta remember to check sysfs. So PC card status works. And libudev Pcmcia socket startup on socket 1. Ooh, it memory probed the area that I asked for. then it's excluding basically all of it. That's fine. I mean, it isn't, but it makes a lot of sense. You know, I don't know for sure that the memory region at E0000 is a problem. Let's look at those registers again. There's probably just got to be a 64K segment in here somewhere that I can use. Alright, so we have cseg, dseg, and eseg. How does F happen then? That's not an MMS window. Right, A and B are used for video RAM. C, D, and E have these mappings for linear ROM 0. Maybe F always has linear ROM 0 decoding, because that's like the minimum amount of memory you'd want to use for the BIOS. Yeah, like here's some flags for fseg. I've got to assume that C through F is just all used for the linear ROM mapping. Yeah, how can I reserve a region of this lower system RAM, maybe? I don't know how high this memory should be, or could be. I think I need to find that out. looks like the I/O windows are full 16 bits here. Plenty of I/O space. Ooh. Do we have 24 bits? I feel like the safest thing to do would be to move the kernel up. Like make a gap right at 1 megabyte for the PC cards. Maybe we could put it above the kernel. Can't put it above the kernel. I think it just has to go in this region somewhere. Oh, can I put it above RAM? I can't, because we have more than 16 megs of RAM. Oh, we have more than 24 bits, though. We have 26 whole bits. Maybe I should put it right above RAM. Let's see if that works. Yunk. I don't remember off the top of my head where the frame buffer window is, but I think it was a good bit higher than this. Just like splatting stuff into memory. Code failed. Did we not even try to probe that memory now? I feel like the probing for high memory was disabled by default. How wide of an address does this actually support? Right, pay drugs. Are these not paid drugs? Oh yeah, this is actually an extension to the 82365 spec. That would be useful for the Linux driver to know we support. Index 1B and 5B. Sure seems like the proper way to do this in Linux is going to be to write a driver that exists as like a chipset specific variant of the i82-365 for this particular chip. It'd be cool if we could just get this working with the standard driver though. Is this just 16 bits? I guess 24 bits. I'm guessing this is 20-bit with paragraph alignment. How does Linux usually use low memory? talking about being low on memory. I'm talking about the low part of memory. Gosh. X86. Right, isn't this just the part of the memory range that is used for the compressed kernel early on and then it gets freed? Right, so the I/O memory hole here that they're talking about, I've got that. I need a bigger I/O memory hole. Like, my understanding is that this is all being used by the BIOS ROM mapping, and I need to put the PC card somewhere else. So what about this? Why can't I put it down there? Right, where does that system RAM come from? Do I need to remove that from my E820 map and add it to the Pcmcia config file? That actually seems kind of sensible, right? Could I just pick an arbitrary 64K segment down there? Okay, let's not try to get away with high memory shenanigans. Let's try, I don't know, low segment 5 maybe? Is anything cool in there? Let's stick it right in an even 8. 8.0 to 8F. Okay, so this strategy is to tell grub to just completely avoid that memory region, and then tell Pcmcia to use it. Or by, I mean, that memory region is one that I made up basically arbitrarily. Linux 5.14.16 on i486. Yeah, freeing unused kernel image memory. Okay, what do we have? Cool, so I made a hole in system RAM. That's good. We have that hole taken up by Pcmcia, hopefully. On probe. Oh. Oh. Whoa, we got a device! That did it. So I don't know why we excluded this top 4K of memory. I'm wondering if maybe this should have actually been all the way to 9,000, and I was like actually giving it 1 byte less than 64K. But whatever, it's got plenty of memory for some I/O windows now. So do we have a Pcmci device now? Whoa, we have a bridge and a device with no driver. Oh my gosh, we can read the card. Wow, what happens if I just try loading a driver? It has an Ethernet address. Whoa. We flipped to 10 base T. Ooh, we might have an interrupt problem. Oh. Wow. We just had to make some room. So yeah, I guess that was the problem. That warning in the manual. Let me find it again. That turned out to actually be the issue. Oh, they've got a similar caveat for graphics memory. Must not overlap with MMS, a PC card window, or linear ROM 0. They just didn't want to have to debug any of the combinatorics in their memory controller, so they're just like, everything's undefined. Was it in the register manual and not here? Maybe it was in the other manual. I'm losing interest in sifting through documentation. We found this warning, or I found this morning when I was looking through docs, and it was indicating that if you overlap the ROM decode region, which is used for the BIOS and the video BIOS on this system, and the PC card windows, that it may just not work right. And I wasn't sure if we were overlapping them, but it seemed possible, and by looking at the registers, it seemed like that was what was happening. The two possibilities there are either it was using one big linear ROM region for the whole BIOS and video BIOS, or it was using these MMS regions to create little regions for each BIOS image. But all the MMS regions are disabled, and the ROM chipset 0 is enabled. So I think what's going on here is that there's actually a giant mapping that's just mostly not used that the BIOS doesn't bother to tell Linux about. And it normally isn't a big deal, but it interferes with Pcmcia. Oh, there it is. In what part of the spec is this? PC card controller memory windows 19.5.2.3. PC card controller memory windows should never be opened in any region that's enabled for linear ROM CS0 decode. Whether or not shadowing is enabled, failure to adhere to this may cause improper system operation because no internal address decoding priority is defined in this regard. So yeah, we'll take that seriously. Looks like we can ping. I should make these configuration changes a little bit more permanent before I totally forget about what I just did. Yay, okay, so removing the Pcmci debug patch. That was just to make a little more disk space. I should check in some of these changes separately. FS tab? I just want to get a new image building, and then we can play around with the network connection a little bit. Just give up on aligning anything. Just makes a white space mess. No? Mm. Fine. I don't know why that was sig faulting when I was trying to open it from the command line a second ago. I don't know if there's actually an interrupt problem or if this is just a performance problem. It seems like an actual interrupt problem. I don't see interrupts. There's all sorts of reasons why interrupt routing might be broken. We could also try the other slot to see if there's any difference in how the two slots behave. Can I actually ping the internet? No, I can ping the whole internet from here. Can I install Vim? Vim is actually kind of big. Let's see if we can actually install a package from the internet on this machine. We're missing some SSL stuff. Or maybe we just hadn't ever fetched these here. Yeah, I don't know why certificate verify is failing here. Ooh, maybe because it's 2099. Gosh. Do we not have NTP date? Okay. We got a date from a local NTP server. Now can we update packages? wouldn't be surprised if this works very badly if we're actually just dropping all the interrupts. Like, it must be polling to get anything back. It's making some progress. Oh, Tuco. Loud boy. Whoa, don't. I need that. That's my console. Oh, Tuco. Are you going to find a different cereal port to eat? Hey, don't. Whoa. This one is normal. That /packages directory is where I put my custom packages during build, but then I removed them to save space. Got some packages. Can we do a figlet? I wouldn't be surprised if there's some other completely weird IRQ routing problem going on this motherboard. There's a request for some context. I'm trying to get Linux running all right on this old 486-based voting machine, and I just got it connected to the internet. We have a Pcmcia Ethernet card in there. Tuco, don't scrape the screen. I got the I/O for the PC card working just now. The IRQs seem to maybe not be working, but we are still connected. And we just installed a package. So I think the next thing to try is network block device. I already have a server ready to go for that, I think. Tuco, are you trying to break that? So, by the way, if anybody cares about the source code to this, I did put it on GitHub. It's there at scanlime/avc-edge-linux, or avc-edge-linux. There's not much, it's just a bunch of patches at this point and a big Docker file that builds everything. Tuco, don't do that, boy! Is he doing that when I scroll the screen? No, he's not paying attention. So, make NBD should run an NBD server with this big ol' netroot. Okay. Oh, Tuco, gosh. Gosh, Tuco. Okay, host port block device. Do we even have udev at this point? Yeah, I don't know why my init scripts are all broken right now. Yeah, now we're mounting stuff. Thanks, udev. Oh, hey boy. Oh, Matuko, you're pressing keys. Matuko. Okay, how do I do this? So far, all the modules I'm loading have that invalid L structures warning. I'm assuming that's some debug info that this kernel doesn't recognize. Yay! Thanks, udev. I have block devices now, the network kind. So I can load modules, I can run udev. Oh, I feel like I should start this inside tmux. I do have tmux, right? Good. Okay, host. Huh. I think that's a gigabyte. I don't have ls block. Can I install ls block? Anyway, how about netroot? Ooh. Interesting. Hardware sector size. Well, I might have to change that later when I do, I'm accumulating things to fix in my build scripts so that I can build a better disk image for this next time. I think right now I can just make a new file system here. Yeah, Tuco wants to go. Hey, boy. You wanna go? You should go. You wanna go? You should go. Cool. Oh gosh, I'm almost out of time for this stream. Let's try to get a file system up real quick though. Do I not have makefs? Anyway, I've got to log off soon because I just realized how late it is. But I will be back with this soon, hopefully cleaning up a few of the rough edges here and getting back to trying to make use of this network connection. The main breakthrough we just had on this stream was finding a configuration change we can make to the Pcmcia drivers that actually get it kind of working. It seems like there's still a problem with interrupt assignment, but the card was recognized, the driver is binding to it, it's basically sending and receiving packets correctly, and here we are installing packages over the network. And I'm having some file system problems, but it does seem like we have a network block device here. Right? Here's a disk image that it's reading over the network from a different machine. So yeah, I think I'm going to have to leave it there. I don't quite have enough time to debug this on today's stream, but this will be a nice juicy morsel to dig into tomorrow. We will have an actual network file system for this little thing. So yeah, I will bleh. Sorry, I'm trying to wrap this up quickly and getting a little disheveled. I will see you all tomorrow. Thanks so much for hanging out, and special thanks to everyone who donates to the stream on Patreon or tells their friends about the stream. You are making this possible and helping me come out here every day and record some techie weird stuff for you. So if you like that, I will do my best to continue, and I'll see you tomorrow, resuming all of this and petting the cat and all that. See you later, folks. Oh yeah, and all the links to stuff I think are either in the description, or if you go to my website scanlime.org, it has like videos and links and stuff. See you tomorrow.